This video is for The Living Earth, Unit 3.6, Mechanisms for Evolution. Evolution is the change in a population's gene pool over time. Therefore, the population is considered the unit of evolution. The Hardy-Weinberg equilibrium is a principle that can be used as a baseline against which changes in allele frequency among a population can be measured. The principle states that in the absence of disturbing factors, different genotype frequencies in a population will reach an equilibrium and will remain stable over generations. However, the Hardy-Weinberg equilibrium also states that evolution should be expected in all populations virtually all the time. This is because populations in nature always experience disturbing factors such as mutations, selection, migrations, genetic drift, and changes to their environment. Conditions of the Hardy-Weinberg equilibrium. If the allele frequencies change, then the population is not in equilibrium. This is true of every population in nature. Hardy-Weinberg equilibrium is possible only for an idealized population that satisfies the following sets of assumptions. 1. No mutation. 2. No migration into or out of the population. 3. Infinitely large population size. 4. No natural selection. 5. No sexual selection, which means random mating. And lastly, organisms are diploid, and allele frequencies are equal in both sexes. Clearly, these requirements cannot be met in nature. Therefore, in all real populations, evolution wins over equilibrium. Using the Hardy-Weinberg equation. The Hardy-Weinberg equation can be used to make predictions about a population. The Hardy-Weinberg equation for a population in equilibrium is p squared plus 2pq plus q squared is equal to 1, where p is the frequency of the dominant allele and q is the frequency of the recessive allele. So, for a gene with alleles big P and little p, the equation representing possible genotypes in genetic equilibrium is the frequency of big P squared plus 2 times the frequency of big P multiplied by the frequency of small p plus the frequency of small p squared is all equal to 1. The Hardy-Weinberg equation can be used to make predictions about future generations' genotypes. Here's a quick sample problem. If there are 200 big M alleles in the gene pool and 800 small m alleles, then we plug that into our equation. 0.2 plus 0.8 is equal to 1. In addition to that, 0.2 squared plus 2 times 0.2 times 0.8 plus 0.8 squared is all equal to 1. The Hardy-Weinberg equilibrium is never achieved in nature, remember, but it is very useful in studying populations. At this point, you should be able to generate a full and appropriate response to today's essential question: how can the changes in allele frequency within a population be measured?